Good morning, everyone. Welcome to our March Whiteboard to Boardroom webinar. My name is Robin Baer, and I welcome you. And I'm going to turn it over to James Baxendale, who is going to introduce our presentation today, along with our speakers. Jim?
Thank you, Robin. My name is Jim Baxendale. I work with the Whiteboard to Boardroom program, and some of you may be new to our webinar series, and these technologies presented by our institutional partners are available for licensing to form new startup companies or as new product opportunities for established companies. In some cases, you may find that we'll be presenting some newly formed startups that may be seeking CEOs, capital resources, strategic partners, board members, advisors, those types of things. So our presentations generally last 10 to 15 minutes or so in length. We'll have a few minutes there to take questions. Feel free to use the chat feature if you like. And if there's some questions following the presentations, you can always reach out to us. The presentations are recorded, and we will send you a link to those to the presentations in a few days. And we actually encourage you to share these presentations with your colleagues who you think may have an interest in this technology. And also other colleagues you have that you think may be interested in our webinars in general. Feel free to reach out to us. You can actually refer them on to us through info@whiteboardtoboardroom.com. So today our innovation is coming from the Missouri University of Science and Technology. And we have two presenters today. John Woodson is the Interim Director of Technology Transfer and Economic Development in the Office of Technology Transfer and Economic Development at Missouri University of Science and Technology. The inventor, Mohammed El-Gawadi, PhD, full professor in the Department of Civil Engineering at the university. He's invented an improved jacketing repair system for steel H-beams. Steel H-beams have been used extensively in bridges and other infrastructures. So with that, gentlemen, if you'd like to get started, that'd be great. Thank you.
Thank you for the introduction, James. Good morning, everybody. I am John Woodson. As James has said, I am the interim director here at Missouri S&T, and hopefully some of you can find this interesting, useful, or at least intriguing. Please go ahead and move to the next slide. So what is the problem? Of course, damage, corrosion, any kind of environmental effects on H-beams that are being used in infrastructure, in construction, whatever the case may be. The amount of bridges, the amount of pilings, the amount of infrastructure in the United States that's being exposed to different chemicals, different weather environments and all that, it's astronomical how many bridges and other structures are out there that are getting attacked by the elements and other things that we use to clear the roads or whatever the case may be. The cost and the time of repairing all these are just as astronomical. The inconvenience it'd be to commuting, to travel, to getting products to market would be very, very time consuming and costly, of course. So what are we trying to do here? We're trying to find an economical, efficient, better way to repair them than having to tear down structures and totally redo them. As you can see here from the bullet points, there are extensive numbers of bridges just here in Missouri. There's over 10,000 bridges just here in Missouri. Missouri has the fourth highest number of deficient bridges in the US, with more than 3,000 needing repair. And of course, many of these are constructed with steel H-piles. Next slide, please. So how does this product, how does our solution work? So of course, instead of demolishing the bridge or rebuilding the bridge, what Dr. Agwadi has come up with is an efficient, durable, fast way to jacket the H beams and then put in reinforcing concrete in there and repair them and get them back to their original strength and everything that's needed there. One of the things that we do is that he has used a specific type of methyl methacrylate polymer concrete, a variation of a better variation, an improved variation of just regular concrete to pour into this jacketed system. Dr. Agwadi, would you like to talk more about that?
Yes. So this is relatively a new type of concrete that has a much higher kind of, if you like, a glue with different materials. Okay, so as the name probably showing, it's a sort of polymer. So it's a combination of polymers and concrete at the same time. So what you need to do is to have the like the steel jacket around the pile, place the concrete, and we did some tests. John, can we go to next slide, please?
Well, one thing I'd like to say right quick about that one, sorry. We can vary also how much of the beam we're covering, right?
Yes, you can determine this based on how much loads you would like to recover.
Okay. So we're in the next slide there. Do you want to go ahead and go with this, Dr. Agwadi?
Okay. So H piles are not only for bridges. Bridges are really one of the main things, but also it has been used for docks. It has been used also for high-rise building. So whenever you have, the advantage of H pile, it can carry high axial loads with a very minimal cross-sectional area that penetrates your soil. So it gives like a very minimal disturbance to your soil. This is why it's very popular on the markets. Most of those were built like in 1960s, 1970s, where most of our bridges are suffering from corrosion because it's embedded on the soil.
I believe that most bridges were built with, back when all the departments of transportation were building the bridges and the highway system was quote unquote new. Most bridges had an expected 50-year lifespan. And
exactly.
That's fine, but here we are 50 years later. And again, with the population growth, the population density, even out into the rural areas, to be able to tear down a bridge and replace it. I'm sure everybody on the call has been through countless construction zones where bridges are being repaired. The time and inconvenience is truly mind-boggling.
The average age of a bridge on the United States is about 47, 48 years old. With a design life is 50, so we're almost there.
And again, right now, all the departments of transportation, U.S. Department of Transportation, MoDOT, they're faced with a choice to either extend the life of the bridge, which is still going to have its own time constraints, but it's much more practical right now, or demolish the bridge and replace. And we are here to hopefully extend the life of the bridge. And also not just the bridge, like Dr. Agwadi was saying, you can see from the pictures there. Think about how many container ships come into our nation's ports, and think about the environments that those piers are subjected to 24 hours a day, 7 days a week. So even if we're not talking about the bridge and the inconvenience with getting in and out of urban areas or getting products to market, we're still talking about getting products to market with all the ports throughout the United States.
And every Department of Transportation is really struggling to find the money for repair. So providing a more economical solution is really a key changer for the Department of Transportation. Right now, the situation of bridges are bad. But if we would like to keep the situation as it is, with as much as bad the Department of Transportation need to spend more, about 20% more than they spend right now.
And honestly, the 2020 and even now in 2021 has exacerbated the situation because the lack of travel, the lack of people spending money. All the states are suffering from less gas tax and other revenue streams, right? So the pinch has even gone further to everybody's budgets, especially for the departments of transportation.
And I just would like also to add one more comment when John was talking about Missouri, the fourth worst state in terms of bridges that need repair. This has happened because we collect one of the lowest gas tax in the nation. I think we are also third or fourth. So we don't have enough resources to repair.
So next slide, please. So there is competition out there. These are a few of the commercially available competitors out there, but a lot of these have a different system than the new concrete that Dr. Agawadi is talking about. A lot of these are epoxy based, which are more expensive. Conventional concrete, which you still end up with the same situation in a much shorter period of time due to its inability to resist all the chemicals. You know, the runoff from the roads, the salts, the other chemicals we put on the roads, the corrosive environment at all the docks that we were talking about.
The other thing that I also would like to add for the for conventional concrete, the jacket would be much heavier. It would be much longer in terms of length that you add to the mile because the strength is not enough to transfer the loads. The beauty about the polymer modified concrete is it acts as glue. It has the polymer, you know, as part of the material itself. So probably a 10-inch jacket from conventional concrete is equivalent to probably 2.5 to 3-inch height, a high polymer modified jacket.
Dr. Aguadi, I believe there's a question in the chat which you might be able to answer better. What is the life expectancy? What is the life of this repair, and how much more life can you extend a bridge?
Well, the new concrete, the polymer modified concrete, is much more durable than conventional concrete. So they expect at least another 50 years with the polymer modified concrete.
Thank you.
Thank you.
Next slide, please. Right now, we have filed a provisional. It is good through July of this year. So we are in the process of going ahead and starting converting that. So if anybody on the call is interested, now would be a great time to reach out to us because we can start figuring out international applications if that applies or interests you also. Next slide. And again, I will leave this to you, Dr. Agwadi.
Okay, just a minute. My computer is slow. So we did a lot of tests that to verify the concept. So the first thing is we'd like to determine how much shear transfer. Like, you know, you are pushing the pile and you would like to ensure that the jacket acting as a bridge that transfer the load from the good part of the pile, bypassing the corroded section, go to the other side of the pile. So in order to determine how long is the jacket, we looked at a different jacket configuration. So if you see some of the jackets are more like cylindrical shape, the others are more prismatic. And what we do is you have the steel piles, we have this jacket, and underneath the jacket, there is like, you know, a 2-inch gap. So whenever we are pushing the pile, there is 2-inch gap underneath the pile. And when we push, the pile can slide in the jacket when we exceed the strength of the jacket. Next, please. So for further testing, we would like to look for fatigue testing. So bridges are subjected to cycles of loading and unloading, and we'd like to see how those cycles of loading and unloading would affect the cohesion between the pile and the jacket. We also, all our testing is under concentric load. That's mean the load is applied just on the middle of the pile. But in many scenarios, the pile is subjected to the load with a little bit of eccentricity. That means it's not really on the middle of the pile. And also seismic. Missouri is not a seismic, like, high seismicity state, but if we'd like to apply this in other places, we would like to see how this would affect the seismic. We expect this one to be much better in terms of seismic resistance than the original one, and also compared to the conventional concrete jacket. Next, please.
Oh, Dr. Aguadi, okay, no, we're here. We're fine, that's fine, that's fine. I was gonna bring up a couple of questions that were in the chat. There is one that says, how is training handled? How much does it take to train people to do the installs? I'll take a shot at this. Right now, I don't think we've gone that far. I do not believe that there'd be extensive training. Most of it, again, has to do with picking the specific portion of the HB you're going to need to reinforce, you're going to need repair, and then the best mixture of the polymer concrete
You know,
to do that for the elements.
sorry, John.
No, that's fine.
But when we do this on the lab, our students, like graduate students, did the work. So if graduate students can do it, then I don't see any problem for any skilled worker to do it. It's very straightforward. It's similar to conventional concrete when it comes to applying the jacket, and the material comes with its specification as well. So it shouldn't be that really hard to train the skilled worker to do this.
I would assume most anybody that's already in the business, most of the contractors that are applying for these jobs with the Departments of Transportation have what they need to go ahead and incorporate this into one of their offerings.
Looks like, John, there was another one there about sources for the raw materials.
Dr. Aguadi?
Yeah, I'm just trying to see because there are many questions here. So yeah, the sources for new materials. There is a company that provide the polymer concrete for different applications. So we use one of the products. So that's available in the market, readily available in the market. For the jacket itself, this is just a formwork it's really, I mean, you can manufacture this one. It's not really a big issue.
Right now, I believe some of the forms you guys are 3D printing here on campus, correct, Dr. Aguadi?
Yeah, but I mean, the material itself is like, either the 3D printed or the material itself is really very basics. I mean, we didn't really use very high tech, in any sort. So the idea is really the one that's really innovative here.
So what are the next steps here for you in terms of finishing out development? What's your needs? What's your timing? Do you need a strategic partnership of some kind, or what would that look like?
John, would you like to start with?
Yeah.
So I think in terms of testing, we need some more money for the remaining testing. So I would guess, maybe another 200, 300K for finishing testing. And after that, I think it should be, we starting the applied part. John, would you like to add anything here?
I'm sorry, I missed the question. Someone was trying to get in the office and I had to run through what was happening.
Yeah, I was just kind of asking about, John, kind of next steps, what's needed to finish out development or strategic collaborations of some kind, just to kind of finish this out.
What I would personally like to see again is someone be interested in licensing the patent. Of course, that's always my dream and my goal here. Right. But I'm not sure we've done much environmental testing, right, Dr. Aguadi?
No, we didn't do much environmental, but since the material is not really new itself, I don't believe that the environmental side is remaining. The few tests that I mentioned, fatigue and eccentric seismic, those are really the one that we need before we, start applying this. And
there would already be some data on the polymer concrete, right?
Yeah, there is data. I'm sure there is data available on the literature for polymer concrete, because
and with our jackets, again, we can use any material someone wants to use, correct? It's just we're getting the best results with the specific polymer concrete.
Yeah, well, the polymer concrete is much better than, we tried many different, like many types of concrete, and the polymer concrete is really the one that works best.
So, John, for a strategic partnership or licensing or sponsored research agreement, what types of companies would be good candidates for that, do you see?
So I would believe it'd be either someone that's already in the business of working with departments of transportation, do some of the repairs,
Mhm.
or someone that's in a manufacturing business wanting to start manufacturing the jacketing system. So
I
either
see.
one of those, I think, would be the best fit.
Yeah. And in terms of the new concrete, are there other applications for that itself in some way? Have you looked at that or thought about that?
Well, this concrete has more kind of the main characteristic of this concrete is kind of the glue ability of the concrete.
Mhm.
It's kind of cohesion is much higher than conventional concrete, or even like more of the fancy concrete like ultra high performance concrete. This is better than those. So like the compressive strength of this concrete is not that high. It's 10,000 psi, which is probably double the conventional one. Conventional one probably 5, 6,000, 3,000, but this one is 10,000. But this is not really the main feature. The main feature is its ability to glue two things. So whenever you have a situation that you need sort of glue, that's really the best concrete.
So the way I simplify it, because I am not a civil engineer, it is a concrete, but it acts like an epoxy, right? Wouldn't that be a great way to describe it, Dr. Oglati?
Yeah, that's this is why it's called polymer concrete. So it's a combination of concrete and polymer.
Okay.
So think about, for example, I was thinking about, for example, if you would like some of the old bridges, for example, in California, they have a short rebars. Like whenever you provide rebars, you need to have what we call the development length. You need to have an extended length inside your structure. So most of the old bridges in California, for example, they were built with a short development length. So you don't have enough development length. Solving this issue is really very difficult. So what I'm thinking, for example, with this concrete, because its kind of glueness is much higher than conventional concrete, it could be one of the solutions for this issue in California.
Mhm. And there is a use for this as piers in building structures, is that right?
The steel pile, the H piles, yes.
Yeah. Okay.
Yes.
Okay. Does that change the efficiencies of putting a building up in any way? Any additional effort required or cost that you see with what's currently being done?
Well, remember, those are mainly used for repair. So you have a building, a multi-story structure, and you have, the steel piles. You have corroded piles, and right now, one of the methods, for example, that Missouri DOT is using is just to go ahead and jag the bridge, carry the bridge by other temporary, columns, and then cut the pile, the corroded pile, the corroded section, and replace it. So think about, all this effort to cut, add the new section, welding, it's a lot of headache and time and cost.
Yes.
This one, you can go as short as like 5-inch jacket, like the length of the jacket across the height of your pile is only 5-inch.
Okay. Okay. Any other questions out there at this point? I think the chat is open.
There is one in the chat that I'm not quite sure we tackled.
Okay.
We've been talking about this technology use for repair.
Yeah.
Is it possible that it can be beneficial to use in construction of new bridges and other types of construction you all have been talking about?
You can, but like, looking at the economy of the construction, I don't think it would be competitive for new construction. Its competitiveness on the repair market is excellent, but when it comes to new structure, I don't see it there.
Yeah, I think on a new structure, it'd just be an added cost, because with the new
Mhm.
structure, you already have a brand new, solid, certified H-pile, H-beam. So you don't need the reinforcement at that time. I guess if you knew there's going to be a specific point of contact that was going to be subjected to quite a bit of either salt intrusion or some other intrusion, this might help extend the life of the H-beam, but I don't think we really are at a point where we could guarantee that, right, Dr. Oglawati?
Yes, and especially like most of the right now you have corrosion protected H piles or H beams available on the market. It's a little bit more expensive, but you can find some of the galvanized steel, for example.
So at the point with new construction, that would probably be the most efficient way to proceed.
Yeah.
Yeah, okay. Well, very good. I don't think we have any other questions at this time, but if you think of some later, or some of the your staff out there have some questions to put forward, I'd be happy to facilitate that. So thanks again to John and Mohammed. Great presentation, and we really appreciate that. So, okay, everyone, have a great day. Thank you.
Thank you
Thank
for
you so
having us,
much.
everybody.
Thank you, Bonnie.